Brilliant, thanks, Holly. So I asked Chris to come along and speak this evening, having heard this talk early this year, because I thought it'd be a great talk to tie us in with the GeoSoc's Year of Sustainability. So Chris and Miles are going to just talk us through the project they're working on, the Colne Valley Western Slopes, and I'll pass over to them. Thanks.
Yeah, thanks, Sarah. So yeah, the presentation's on the Colne Valley Western Slopes. It's part of High Speed 2. The presentation was originally delivered at a climate change resilience conference for Nicole, so it's largely geared towards that. But yeah, it's how we've embedded technical solutions for climate resilience within a large infrastructure project, and yeah, I'll get into it. So in terms of the project background, I'm sure a lot of you are pretty familiar with ISP2, but essentially it runs from London through to Birmingham as phase 1, which is the phase that we're working on, a small section of that. And then there's phase 2A, which runs from Birmingham to Crewe, and phase 2B running to Manchester and East Midlands Parkway. The section to Leeds is currently cancelled. So the area we're working on is the Central 1 contract area. So it's just west of London, roughly shown here. It's been delivered by a line, which is a joint venture between Bouygues, Robert McAlpine and VolkerFitzpatrick. The area includes a 16-kilometre twin-bore tunnel through the Chiltern Hills, so running from the Colne Valley Western Slopes through to North Portal. So the South Portal is around here, and it runs all the way up to the North Portal. There's a series of vent shafts along this section, so there's 5 vent shafts in between. And there's also a 3.5-kilometre viaduct over the Colne Valley. So this Colne Valley Western Slopes, where we're focused on, is situated with the north embankment of the Colne Valley and the South Portal area. And Jacobs providing multidisciplinary design and construction support to a line for around about 4 years now. Also, just to say that these vent shafts are situated within an area of outstanding natural beauty within Chilterns. I mean, part of the reason why it's actually going through the Chiltern Tunnel in the first place, and the Colne Valley Western Slopes, as well as within a regional park, the Colne Valley Regional Park. In terms of the site setting, so the site was former arable farmland, about 140 hectares in area. You can sort of get a picture of that here. This area here was actually a quarry when we took over the site. That was for sand and gravel extraction. And the rest of it was arable farmland. But you can see here the beginnings of the construction compound development. This photo was probably taken 2 or 3 years ago now. It's quite a sensitive groundwater environment, so there's a principal chalk aquifer underlying. Lots of public water abstractions through the Colne Valley, and we're also in source protection zone 1, very close to. The groundwater is also quite shallow in places. It's pretty variable given the variable topography. It's quite undulating at the site, but the groundwater can be as shallow as around about 1 metre, particularly in the former quarry area, but goes up to about 32 metres towards the South Portal. I'm going to hand over to Miles now. He's going to give a bit of an overview of the geological setting.
Thanks, Chris. Right. Obviously, we're on the dip slope of the Chilterns, so where the chalk is dipping down towards and under the London Basin, and the full extent of the C1 contract is founded on the chalk. The very extreme end of it, we just catch the edge of the London clay, and we've got a bit of Lambeth group in between. So if we look on the old geological map on the left, it gives you a feel for where we are. So the principal strata is dipping very gently towards the southeast, but it's all chalk. What we would traditionally call the upper chalk, we now call the white chalk. On the right, we have a close-up of the geological map extract showing the area of the Western Valley Slopes, and to the to the right of it, where all these hatchet lines are, these are all gravel quarries in the Colne Valley. So most of those are flooded. So we're effectively the leading edge of the chalk upland before we started ripping the place apart so we could put a railway through it. There's a small amount of Lambeth group, and what isn't shown on the geological map, which is quite regular in this part of the world, is there's a relatively thin covering of drift over the entire area. So some head deposits. There's claywood flints further northwest, but not found here. So we get winter hill gravels, we get alluvial gravels, and we get stuff derived from the chalk itself. Next slide, please, Chris. So a quick grab, as I say, we're looking north here approximately. So Lambeth Group sitting over Seaford and New Haven formations. It's designated as undifferentiated. We couldn't find any New Haven formation. It's all Seaford chalk in this part of the world, and it goes down for a significant depth. Next slide, please, Chris. So a quick look, as I said, for the cellar geology, chalk, Lambeth Group. On the left, you've got a vague indication of the topography and this interesting split feature. So we have a dry valley running east-west across the middle of the site, and we have dry valleys extending north and south from that. Our experience on this particular job, where we've literally done hundreds of boreholes, is that there tends to be faulting along the dry valleys, which is something that when I was starting off in this field 30 odd years ago, we didn't know the relationship between faults and the topography. So we've picked this up quite well in this part of the world. So none of it's particularly capable anymore, but the faulting seems to have been the line of preferential erosion, which allows the formation of the dry valleys along these lines. We also get solution features, typically concentrated where valleys join. Next slide, please, Chris. Okay, here's one fragment of our ground investigation plan, which gives an idea as to how many boreholes and investigative locations that we've picked up. So this is the southeast corner of the area that we're covering. So the Pinesfield quarry in the centre of it, which was a gravel pit that we've dug out, and we're going to bury that in the arisings from the tunnels, which Chris will explain, and the main line of the railway runs across the bottom of the plan here. So again, a lot of ground investigation. We were quite blessed on this job to be able to have almost as many boreholes as we would like. A luxury. Next slide, please. Quick extract from Clayton et al. Of 2003 as to the typical formation of the chalk throughout the southeast, if it just has a topsoil lurking over the top of it. This profile with structures chalk at the top, now referred to as DM and DC, and then into the structured chalk, what we'd regard to as varying degrees of weathering with depth. This was found throughout the scheme, and yeah, in some cases we've got 20 meters of overlying material where it says topsoil here, but we still get that structures chalk at the uppermost and running through into the structured chalk at depth. And this is the type of formation that Chris is going to try and represent or recreate with his project that goes on from now. So over to you, Chris. Oh, no, tell me
one last slide.
One last slide. I thought I'd include this one. This is actually a recent one from Google, which shows the area that we're working in. It's all going to go back to landscape, but at the moment it is a huge factory site with a railway alignment diagonally across the middle from bottom right to top left. You can make out the location of the tunnel portal. hopefully. The rest of it is factories to make tunnel segments. There's a plant to deal with all the chalk arisings from the tunnel. It's a huge site, and we're going to have to tidy it all up afterwards. I'll now hand over to Chris properly.
Thanks, Miles. So we're going to talk a bit about the design vision then, to, as Miles said, to try and clean up after all this construction. This is the master plan in terms of landscaping for the site. It's slightly superseded, but it's essentially the same thing. Effectively, we've got around about 136 hectares proposed of calcareous grass and habitat, along with wood pasture and wetland habitats. So calcareous grassland is this sort of light shaded green area, and then we have woodland pasture with these areas grading into full mixed woodland around the railway and the embankments either side of it. It's the largest area, or will be the largest area of calcareous grassland in the Chilterns if we manage to achieve it. And it'll also be the largest single contributor to net biodiversity gain within the HS2 route as it stands. Obviously, with the woodland either side of the railway, the idea is to also mitigate the effects of that and integrate it into the surrounding landscape. So that's why you do have a lot of woodland around the edges of it. This is an aerial overlook, or an image of what we'd like to achieve with the site and the landscaping overlooking the south portal. And it really gives you an idea here of the sort of mosaic of habitats we're looking to create through this grassland, with this scrub habitat interspersed, trying to recreate what you'd naturally find within the Chilterns. So in terms of the construction then and what it looks like now, this is a drone image of the site. So similar to what Miles just showed a minute ago from Google Earth, but slightly updated. So as you said, there's lots of plant, and the main construction offices up in this area here, the south portals here. In this area down here, it's the largest, it's the area where we're depositing the most chalk cake. So this is the stuff that comes out of the Chiltern Tunnel. As the tunnel boring machines go through, there's chalk is brought out and processed in this area here, and it's reprocessed effectively into what we're calling a chalk cake, which is destructured chalk slurry as it comes out, and is it's quite structureless by the time it's processed. And our job is to try and then work the landscaping off top of that. The majority of that 2.5 million meters cubed of chalk cake is being placed in the southern quadrant, so up to 20 meters thickness in this area here, the former quarry, but also being spread in this area in the southwestern quadrant, largely sort of around about a meter thickness or 2 or 3 meters thickness in this area in places. There's also a small amount being placed up around the south portal hood behind that. As I say, it's the main construction hub for C1, so there's a huge amount going on here. Just to give you an idea of the scale of it then, so this is looking towards the two portal structures here, towards the twin bore tunnel, and you can see the M25 in the background here, the image, and some of the processing plant for the chalk cake. This is actually where the chalk cake comes out and gets deposited here off the filter press. And there's more of a close-up of these portal structures, so they are pretty big. This is just showing some of the chalk cake as it's come out and loaded into dumpers before being taken to the landscaping areas. You can see here the chalk cake being deposited within Pinesville Quarry, so it's being deposited off haul roads that run through it, cement stabilized, and then it's placed into these areas of landscaping up into sort of 1 meter thickness. I think the layers are now. It was originally kind of shallower thickness layers, but now are being deposited in thicker layers. I'm just going to show a video now to give you a bit more of an understanding of the scale. Hopefully this works okay. So I'm just going to skip forward to where we get onto the south portal, because this is kind of covering the whole of the C1 area. So this is following on from the Joss-Peter vent shaft, the first of the vent shafts, and taking into the south portal here. So it's giving you a fly through of the site. So you can see some of the processing plant around this area. Here you've got the chalk storage sheds here. So when it's or whether the cake gets stored there under the storage sheds to dry out before placement. There's some of the viaduct platforms here, the segments. So some, hang on a second, sorry, just yeah. So some of the viaduct segments. Sorry, my Teams keeps popping up. So you can see one of the viaduct segments being lifted into lifted across here. These here are the tunnel segments for the south portal. So these are all precast before they get put into the tunnel. Again, south portal on the left there, and giving a sweeping overview of where the chalk is being processed, storage sheds, and where the other factories are for precast segments. In the background here, you can see some of the water treatment ponds here, and Pinesville Quarry down here with all those landscaping areas. This is following the trace of the railway here with the false cutting, I think that is there on the embankment, and Pinesville Quarry again down this area where the chalk is being placed. This here is the launching girder for the Colne Valley, so that Colne Valley viaduct extends through to the south there. Again, this launching girder. You can see one of the Colne Valley lakes in the background there, those former sand and gravel pits, which have been, which are now a series of lakes through the Colne Valley. And that's it. So it gives you kind of an overview of, the site there as it stands. Let me a second, let's go to next slide. Okay, so I'm going to move on now to the technical solutions for climate resilience and biodiversity that have been implemented at the site. So the first of these is sustainable remediation. There are several historical landfills present at the site when we took over or we started assessing the site. Asbestos and lead were the main contaminants of concern, but also in this area it's particularly nasty landfill. The quarry operator who took over, who was originally on the site, remediated part of this, but left a section of it in situ, which is outside their permitted boundary. So what we did was undertake detailed quantitative risk assessment for controlled waters, because there were outstanding risks that fell out of the risk assessment. And we went through the SURF UK framework in terms of looking at the remediation options. So generally what this showed was that a cover system is the most sustainable in terms of the environment, excavation and disposal being the least sustainable, and then the stabilisation solidification option being somewhere in the middle. In terms of the social impacts, again, cover system came out more favourably, albeit you might have some long-term risk management to deal with if you've got outstanding risks. Economic factors, excavation disposal comes out more favourable in the long term because obviously you remove the risk, but in the direct costs it's significantly higher than obviously implementing a cover system or stabilisation solidification in this case. And then lastly, this table at the bottom just giving you sort of a summary of what it came out as. So the cover system was advised the most appropriate solution, and there wasn't anything here to change in terms of the design as such, because we're already planning on putting chalk cake over the majority of these areas. The only thing was making sure that it's extended out in certain areas and making sure we had sufficient thickness in terms of the cover over some of these southwestern landfills. So there were some slight design tweaks as a result of that. And for this northern landfill here, actually, it was being intersected by the railway as it was. so it wasn't really possible to, implement the cover system in that case, and there was some excavation disposal required of that area intersected by the railway. The second of these technical solutions owns sustainable materials reuse. So, as mentioned, the majority of the chalk cake is being placed in the southern quadrants. This is slightly outdated in terms of the chalk cake placement because it does actually extend much further out in terms of that chalk cake, but you can see the majority of it being placed in these areas as a visual. And this here gives you an overview of the sort of cut and fill versus pre-construction ground levels. So again, you're getting the idea that it's up to 20 meters in this area. That's where the majority of that's going. So one of the key objectives was then to obtain that, so retain the chalk cake on site, because say 2.5 millimeters cubed, there wasn't really any other option than to keep it on site in terms of obviously off-site haulage and any other practicalities. So the only difficulty with that is that there are potential risks to controlled waters from that placement, largely because there was treatment with cement to make the material suitable for trafficking in the haul roads. A polymer supplied as it comes off or as it goes through the filter press to make sure it comes off cleanly and is suitable for placement. And that polymer was originally it replaced a hydrated lime, which was originally going to be used in the filter press. But there's also quicklime being added to the material to try and dry the chalk cake out, to make sure it's suitable for trafficking as well. So there's there's quicklime applied in certain areas as well. So what we did was to zone the site into a series of different parcels, essentially. So we have this was to allow us to undertake our DQRA. We had to come up with sensible zones that could be characterized in terms of the groundwater regime and also the fill thicknesses and other characteristics. So, for instance, this zone here, the Pinesville Quarry East, we had to zone in slightly strange shape because we've got a series of band drains that are being installed in this area. So effectively, they're diverting, infiltrating rainwater through to a drainage ditch. So it's actually not entering that infiltrating water won't enter groundwater. So that was effectively taken out of the model in one of our scenarios. And then the rest of them, I say, was mainly based on the sensible zones for the groundwater regime and fill thicknesses. We also had to take account of some other materials. So materials coming from the vent shafts and from the Colne Valley, where chalk cake was being processed, was being taken from those sites for placement here in the West Side embankment. So one embankment's the railway, and around the South Portal cutting. These materials were treated with a different polymer, so we had to take a risk assessment to obtain regulatory approval for that. What we did was to characterize those zones, we undertook statistical analysis of the CAD model. So this I know you won't be able to see the actual text on these diagrams, but the first one's a histogram for fill thickness, so you can get an idea for the kind of distribution of fill thicknesses within each of these zones. And this allowed us to, within Consim, which is the groundwater modelling software we used, to come up with a decent statistical representation of that fill thickness, so that when it runs through the modelling, you effectively get a meaningful output. And the second one was for the groundwater levels, so the unsaturated zone thickness. Again, it's quite variable between the different zones, so we had to come up with sensible statistical distribution for these. There's probably more detail than is normally gone into for this sort of groundwater modelling, but it was necessary in this case due to the scale of the site. We also undertook bespoke leachate testing for laboratory simulated chalk cake. So when we undertook the assessment, we didn't actually have chalk cake from site because the tunnelling hadn't started. So we had chalk cake that was simulated in the laboratory, and we undertook various different methods to get sufficient lines of evidence for the EA as to the leaching profile of the material. So we used methods such as I've put down below. So we had standard sort of 2-to-1 liquid solid ratio leachate testing, batch testing. We had multiple batch tests, so a series of them. We ran the same leachate material through leachate testing 5 times, so to get an idea of the declining source of the material as you repeatedly leach it. we went through dynamic monolithic leachate testing, and this is really for to account for the fact that the chalk cake is partly monolithic in behaviour, particularly within the haul roads where you've got cement stabilisation. It should act as more of a monolith than a granular material. So that was looking at that side of things where you've got reduced leaching. And then we had 10:1 testing for liquid solid ratio, and we did upflow percolation and pH dependence testing. And all this was off the back of consultation with the Environment Agency and really trying to come up with a robust model to assess the risk from the chalk cake. So ultimately, we did demonstrate that suitability for reuse through the DQRA, and we found evidence of a declining source, as you might expect. So obviously, all this is based on laboratory testing of that chalk cake. So what we're also doing is undertaking verification testing. So as the chalk cake is being placed, it's being tested on a regular basis, and also as it comes out of the filter press, it's also being tested there. So both in situ and ex situ, and that really allow us to ensure that we're not departing from what we modelled. So we're verifying those model results. And we're also next week installing lysimeters. So this is shown by this photo here, what they look like. But essentially, you install these installations. You get a column of soil, which is leached through as the water percolates through, and you collect the leachate directly within this reservoir, and then you can pump out the water and sample it at regular intervals. So you actually get an idea of the actual leaching of the material. So you're getting something quite robust there in terms of data set. And these will be installed in trial plots that we're installing for other purposes, which I'll come on to in a bit. But it will really allow us to get us this sort of real world data and not just rely on the lab data. The next of these strands then, keeping on the sustainable materials reuse theme, we derived site-specific assessment criteria for recycled aggregates. So, as I say, it's quite sensitive. Well, it's a very sensitive groundwater environment. This, but obviously recognise that there's potential benefits from reusing recycled aggregates in certain areas, or benefits to the the wider circular economy and avoid landfilling. So what we did was to undertake DQRA again to derive these SSACs for certain areas. So for instance, in the compound area, where the groundwater level is much deeper than in the southern quadrants, or certainly the southeastern quadrant, we derived these SSACs, which were a bit relaxed from our normal limiting values within the earthwork specification. So these are a bit relaxed from your normal drinking water standards or environmental quality standards. What we did find is it wasn't suitable for reuse everywhere, because the groundwater is quite shallow in places, let's say, and we also rolled these out across the vent shafts, not in the Colne Valley because it's too sensitive there. But ultimately, plan to sustainably reuse these materials in the landscaping as well. Also, in terms of materials management, we reused all the material. Well, we are reusing all the materials under the CLARE Development Industry Code of Practice. Nothing new there really, but we did develop a new SAGE declaration approach due to the sort of complexity of the site and the program. This was developed in collaboration with CLARE and EA. Essentially, we declare the materials being reused each year, and it's a SAGE declaration, so it's much easier to track than just kind of trying to declare it all in one go, where you're obviously going to get departures from that because you can't be that accurate, sort of looking 5 years ahead. So I think that this has worked quite well for this site. Moving on then to the biodiversity side of things. So the habitat creation designs have really been led by the soils and substrate conditions. We're looking, as I said earlier, looking to create around 130 hectares of habitat, but this has got to be, contextually appropriate within the Chilterns and work with the soils, and also feeding back into this, achieving a soils mass balance is really central to the design. We don't want any surpluses or deficits at the end. Also, sustainably reusing the chalk cake within the profiles is important, and also those aggregates I mentioned, both primary aggregates that are being imported, limestone aggregate for haul roads and compounds primarily, but also trying to reuse crushed concrete that's arising from the works within our landscaping. So all of this has sort of been feeding back into the design as we've gone along. What we look to do as well is to create a gradation of soil depths and fertility, which should both promote and inhibit succession. So what I mean by that is we've got deeper, more fertile soil profiles within areas of woodland. And as we go through to our areas of woodland pasture, those gradually thin, and we try and reduce the topsoil depth so that we've got a less fertile substrate. And as we get into the calcareous grass, and that really does thin through to just a shallow upper subsoil, which should be low in nutrients and quite high in calcium carbonate to really support a biodiverse calcareous grass and sward. Ultimately, the sort of vision we're looking for is this sort of wildflower rich and invertebrate rich calcareous grassland. So some of the sort of species we hope to see are chalk hill blue butterfly and corn bunting, and this is going to give you a visual of the sort of scrub habitat we'll be looking to create. So to support all this, there's quite a lot of uncertainties, particularly working with the chalk cake. Landscaping over this material hasn't really been done to my knowledge. So we've initiated a research project in collaboration with Cantle University and also Tim Hare Associates. What this comprises is firstly understanding materials a bit better. So we've done various tests at Cantle University and also a specialist geochemical lab. And then a series of laboratory trials. You can see here on the left these narrow diameter columns which we're using to kind of understand what variables we have and how we can scale down to or reduce uncertainty as we go through the design, and then scaling up to larger lysimeter boxes. Within the laboratory, you can see a sort of pinkish color. This is actually within quite a large greenhouse where we can control temperature quite closely. And in conjunction with these laboratory trials, we're doing a series of field trials. So this image in the right-hand side is showing these field trials. It's all down one sliver of the site in the southwestern quadrant. And originally this was just chalk grassland trials, so just focusing on the calcareous grassland, but it's grown to encompass planting trials and also wetland trials. So we've got a really large area here to play with essentially over the next couple of years, and to inform the landscaping for the wider site. We've got, particularly in this southeastern area, we've got a full transect from the woodland through to open calcareous grass and into the wetland over a slope. And in other areas, we've got more controlled plots, which will give us kind of statistically valid results for the research project. But ultimately, the idea of all this research is to inform the landscaping. So we'll be able to refine the design as we go through. We have a kind of working design that we are assuming will be, mostly correct, but the results of all this will feed back into it, and it will allow us to, generate some useful results for other projects using chalk cake as well, and in terms of creating these sort of habitats. So the next thing then is on climate change resilience and carbon. So firstly, the habitats that and plant species selected for landscaping, they've all been based on factoring in climate change, so they should all be resilient to those impacts. The creation of natural habitats rather than arable land, so that arable reversion back to more natural habitats, will dramatically increase carbon sequestration, and we've estimated that somewhere in the region of 54,000 tonnes of CO2 sequestered over a 40-year period. And that's equivalent to about 10,500 passenger vehicles driven for 1 year. So it really can have a brilliant impact in terms of carbon. The carbon footprint will also be reduced by all that sustainable reuse of materials I was discussing. So we've got that minimisation of exporting site-wide materials, and also trying to retain those temporary works aggregates. So that's your limestone aggregate, but also concrete we've got in the compound and haul roads. Keeping all that material on site will obviously avoid export and the associated haulage and carbon impacts from that. Also, our remediation approach using the cover system reduces the carbon footprint further by retaining the material in situ. So we've had very little excavation and disposal other than where it's been necessary because of the design. So just in summary then, presentation focus on the technical solutions implemented to gain consents for sustainable remediation, facilitate sustainable reuse of recycled and primary aggregates, ensure that the soils provide suitable conditions for proposed habitats, and reduce the carbon footprint of the habitat creation through that increased sequestration. Hopefully these principles can be adopted elsewhere to realise similar sustainable outcomes, and the research project should feed into that. Just to leave you with a couple of images. So we've got here what the site looked like beforehand, the image I showed earlier with that former gravel quarry down here. And then this image here is just showing what we're trying to achieve in the long term. So this this landscaping habitat we're trying to return to. And that's it. Yeah, thanks very much for listening. Happy to take any questions.
Thank you, Chris. Really enjoyed the extended version from last time. Yeah, has anyone got any questions? What's the just for someone who's just asked about what's the final timescale on that image, just to put it up here?
Yeah, I believe this is year 15 image, so it's 15 years after landscaping when the trees start to mature a bit. So that's the idea anyway. There'll be a 5-year maintenance and aftercare period, which is pretty standard for these projects, and then the idea is to try and hand over this land to a body such as the Wildlife Trust. We've been in quite close consultation with Herts Middlesex Wildlife Trust about this. So we obviously need long-term management that will support this habitat. You can't just sort of walk away and expect it to thrive. So the idea in the long term is to have cattle grazing on this land. And we need obviously a land manager that knows what they're doing, but we've integrated aspects of the design to support that. So for instance, we've got cattle grids between the different land parcels, but also, here there's the path. So we've got a series of cycleways and footpaths to make sure that it's something the public can enjoy as an open space. And that's something the Colne Valley Regional Park are quite interested as well in integrating into their wider network of the park.
Brilliant. I mean, I went to a conference last week and there was interesting theory about developers and whether or not they could do something on a, they're always worrying about how much, how fertile their sort of topsoil and everything is once they've finished their developments. But there was in fact someone sort of talking about this on a smaller scale of kind of looking at sort of, poorer sort of landscaping and the benefits they've got. So it did remind me of this on a different scale. Has anyone got any other questions? Oh, then we stop there. No, okay. Oh, well, brilliant. Thank you very much, Chris and Miles. That was a very interesting talk.
Yeah, no
Mark,
problem.
Thank you.
Do you know anything about any of the things coming up, Mark? I think Holly's gone.
Myself, no.
Okay, brilliant. Well, I think we've got a couple of field trips coming up over the summer that we'll be finalising for later on after the school summer holidays.
I think the only thing we got coming up from a committee point of view is our meeting fairly soon in July.
Yeah.
And that's about it. And then planning for the next year.
Yeah. Okay, brilliant. Thank you, everyone. Yeah. Thank you.
Yeah, great talk. Thanks, guys.
Yeah, no problem. Thanks for the invite. Yeah.
Thank you. That was really interesting.